Engineering 221, Engineering Economy. This is Lecture 3 for Thursday, the 30th of January, 2014. We'll begin with just a couple of announcements. First of all, as I've mentioned previously, this class is going to be posted online because I'm out of state at an engineering meeting. We'll meet again at our normal place, normal time, on February the 6th, which is a Thursday. Homework number 2, which I'm going to be giving to you along with the link for this recorded lecture, is due on Friday, February 7th. And so that is the day after our lecture, and the reason why I gave you an extra day instead of asking for it to be submitted on the day of our lecture is just in case you had questions that you wanted to ask in class. I anticipate that homework 2 is going to be very straightforward. If you follow the examples that are provided in this class, including a couple of pencasts that I'm going to be editing into the recording, then I don't anticipate you should have any trouble, but I just wanted to be certain that everyone got a chance to ask me questions if they needed them. So I'm going to mention that this recording has several different parts. Some of them are related to the class notes, which is a PowerPoint presentation that I'm attaching to the email that I'll send you. And in other places in this lecture, I'm going to be including pencasts, which is a way of me writing out an example and narrating that example as I go through it. And so, YouTube gives you the option of skipping around to different points in the video, and if you need to skip back to watch those pencast recordings again to help you prepare for the homework, I encourage you to give that a try. This is a chart that shows the cost of gasoline in the United States over the last several years. And so take a moment to look at that. So if you're like me, probably what your eye turns to is the winter of 2008. And right as the 2008 was drawing to a close, there was a financial crisis, of course, and for a lot of people, there was concern that maybe the global economy was going to collapse, along with the end of credit availability because of the collapse of a couple of banks and brokerage firms. And so because world economic output declined, there was less demand for gasoline. The manufacturers and producers of gasoline weren't able to charge as much for it, and so the price dropped. Remember, in our previous lecture, we've talked about the relationship between price and demand. And when demand decreases, then price has to follow. Over time, of course, it's crept back up. And nowadays, the price of gasoline is up around $4 a gallon. But the reason why I show it to you is that we're going to be looking at some techniques today for estimating costs. When we're planning a project, we have to project what we think the expenses of that project might be, even though we don't necessarily have firm quotes from all of our suppliers. Generally, when you get a quote from a supplier, it'll say right on the quote that it's maybe valid for 30 days or 60 days. But people don't want to commit to far in the future of what they're going to charge you for a certain item because their costs might change. And so when we're planning a project that may be several years in the future, one of the techniques that we can use for determining a budget is to look at historically in the past how prices have changed and then to extrapolate that forward into the future. So that's one of the techniques we'll take a look at today, and this figure sort of sets the stage for that. And I'm going to hope that the price of gasoline follows more of the trend, this trend, rather than this trend going into the future, although probably that's a little bit unrealistic. Chapter 3 is important because it sets the stage for a lot of the other things that we're going to be covering, obviously, in the rest of the course. Chapter 4 is really the heart of the course, and that's when we start talking about the time value of money. But before we can project present costs into the future, or annual costs to the present, or future costs to the present, we have to have an understanding for developing the cash flow diagrams that will then be converted into different time frames. And so chapter 4 is a little bit about time travel, converting the future cost of money to present costs and vice versa. But before we can do that time travel, we have to know what costs are to be converted. And so that's the purpose of chapter 3. It's a model or a technique for estimating what the costs will be. And so we can apply the principles of cost estimating both to incomes and expenses. We can use these techniques to estimate what sort of revenues may be generated by an investment or an expansion of a business, and we can also use these to estimate what the costs of producing a good or a service or the cost of a project might be. In cost estimation, the information that is gathered can be used for setting a selling price for items. Often a contractor will have to supply a bid, and whichever contractor submits the lowest bid often gets the work. And so for them to know how much they should bid, they have to have a pretty detailed idea of all of the components that go into the project. Sometimes even before attempting a line of business, a producer will use the principles of cost estimating to find out if they can compete. And an example of that is in the tablet market. There are a lot of electronics manufacturers who will add up the components inside of a tablet and try and decide if they can make a profit or if they would have to sell them at a loss. And Apple is sort of famous for squeezing expenses out of their suppliers and keeping the lion's shares of the profit. And a lot of people have gone out of business trying to keep up with Apple and their tablets. Other uses of cost estimating is trying to figure out expenses, and then if you know what the expenses are, then you can find out how much of an investment is justified to potentially capture a revenue stream. And then cost estimating, if you, at the beginning of a project, come up with a reliable and logical guess of how much the project may cost, then as the project is actually occurring, then you can measure the efficiency of the project relative to that preliminary estimate. And so it can be used as a benchmark for judging productivity. The two primary methods of cost estimation, as described in the book, and just as a reminder, Chapter 3 is as good a reading as Chapter 2 was, and I could tell from the quiz last time that several of you had actually been reading the text, and that was wonderful. But the book goes into some additional detail beyond what's on the slide here, that in the top-down approach, what you're trying to do is use the historical data to extrapolate into the future. So in a top-down approach, I think that in the example of firewood, maybe some of you went online and found out that a typical home needs a wood stove of a certain size, and in the past it cost $1,000, and so that gives you an idea of how much a wood stove might cost now. The top-down approach is just a method of finding out how previous experiences similar to yours in whole have cost or have performed. So it's sort of a broad estimate with not a lot of specific details in it. The bottom-up approach does have those details. It's a way of estimating costs by looking at all of the components that go into the project and breaking the components into subcomponents and finding out what their expenses and so forth are. And so a top-down approach would be when a contractor comes and just gives you an eyeball estimate. Your driveway looks about twice as big as the one I did last week, and I had to charge $5,000 for that, so $10,000. Whereas a bottom-up approach to cost estimating would be where a contractor would actually use a measuring wheel, get the dimensions of the driveway, then think about how much asphalt is needed, how much of a subgrade is needed, the excavation that may be required. And so it's more detailed. And typically bottom-up estimates will be more accurate, although they take more effort to generate. And that effort takes time, and time is money. So Here's an example of using the top-down approach. If you were to look at a particular university and they publish annual average costs, and most universities do that. They say, on average, our students have a cost of, let's say, $15,750, and they'll list what is included in that estimate. In this case, maybe it's tuition and fees, housing, weekly meal plan, and then if you looked over the last several years, maybe you could notice that the costs had increased at 6% per year. So what you could do is you could extrapolate into the future how much that's going to cost, and also by adding the other expenses, maybe if you knew that you would want to include some travel, entertainment, clothing, and so forth. And so what a top-down approach to estimating the total cost of an education would look like is on screen there. In year one, you'll notice that they've multiplied the tuition by 1.06, and the reason for that is it was this year that the costs were $15,750, and if you're going to school next year, then you have to assume the worst, that the costs and the expenses have gone up. And so in year one, it's $16,695, and then in year two, it's again multiplied by 1.06 because it's 6% higher than it was the year before that. It looks like the other expenses, we haven't had any kind of an increase over time for those. So by just not breaking it up into any subcomponents other than tuition fees, room and board, and other expenses, we haven't got more detailed than that. We're able to very quickly and easily come up with a grand total of $93,000 for total costs, which is a lot, right? Thankfully, I think Marshall tuition is lower than that. A bottom-up approach to the same question, if you were going to break the cost of expenses, education expenses, rather than just relying on the university's typical student costs, what you do is for every year, you'd find out how much you were going to pay in tuition and fees. And maybe rather than just saying tuition and fees, you'd actually break it down into the subcomponents there, because as you may know, some students at Marshall who have a lot of lab courses have to pay fees for those lab courses, and the costs are a little bit higher in some colleges than in others. The same is true, I think, of the books. If you've taken chemistry, I think you know the chemistry book is very expensive, but there are some other courses where their book might just be a couple of paperback novels. And so by using a bottom-up approach, you're able to put together a cost estimate that more accurately reflects the costs that you actually anticipate, although it can be time-consuming to generate a bottom-up estimate for multiple colleges. If you're going to apply to 6 or 7 different universities, then it would be really challenging to take the bottom-up approach, where maybe a top-down approach would give you pretty close to the right answer for a lot less work as an initial screening. There is a technique for generating projected cash flows and estimating expenses, an integrated approach that correlates the expense estimations to a plan of work. The plan of work is called a work breakdown structure, and you'll probably learn more about these kinds of techniques in project management. But the idea that we need to be aware of is that there are people in a company, whether it's a services company or a consumer products or an industrial products company, there are people who are planning projects, and in each step of the project there are costs that go along with that. And so if we, doing the engineering economy, are able to assign value to the individual components at each step along the way, then we can find out where the expenses are going to be and come up with estimates. The subcomponents there are to come up with estimating techniques or models, and the estimating models can be based on data that has come from previous projects. Accounting departments can provide past data to past revenues, information on expenses from the past. And so having some sort of pool of data and way of projecting from that past data to the future is the estimating model that you can use. This is a general diagram of a work breakdown structure, and any task is broken up into subtasks. And so level 1 is perhaps build a building. Level 2 would be pour the foundation, frame the building, and put up the walls. And each one of those can be broken down into its components, and those components can be broken up into subcomponents and so on. There's an infinite level, number of sub-levels down to instructions for each person who's working on the project. The more levels of detail that you have in a work breakdown structure, the more time it's going to take to generate an estimate. In a construction project as complex as building a building, if you were keeping track of the daily work of each person on the job, then it would be very challenging to generate a cost estimate based on that level of detail. But if you break it up into less fine pieces, such as shown here, a commercial building project where you're breaking it into foundation, exterior, interior, and then you have a general idea of the subtasks under there, that level of detail may be easier for you to find out. Just as, for example, under mechanical systems, you can find out typically for a building of the size that you're going to construct how much heating and cooling, hot water, laboratories, those sorts of things cost. And so it's sort of like doing a top-down approach, but with more detail than just a top-down approach at the level 1. The integrated approach to cost estimating, this is a flow chart that shows what the planning process would be. And in the planning process, you have to consider what perspective you're going to be using. So in step 1 is you're going to generate a work breakdown structure that summarizes the tasks that have to be completed in order for the project to be done, breaking it up into sub-pieces. Now, in phase 2 that's shown there, essentially what you're doing is you're determining a baseline for measurement. You're deciding what the perspective is going to be. At what point in time are you comparing the costs? And in stage 3, you're determining what level of detail should be used for the estimating. For example, should the data that goes into material costs be based on quotes from several suppliers, or is it sufficient rather than doing that to just have the average costs for those components over the last several projects given to you by the accounting department? In stage 4, you're gathering all of that information together into a single database that can be used for generating costs into the work breakdown structure. And so you're assigning expenses into each of the work stages. And then at the end, you're applying that to all of the possible alternatives. You're comparing different types of materials, you're comparing different types of designs. And so it's beginning to apply the decision-making process after the estimation has been generated. What's shown here, the list from 1 to 10, are different types of costs and revenues that may exist in a project. We've already seen some of this when we were considering what types of things would maybe be considered direct costs versus indirect costs. We talked about in class exercise about a business that sells ice cream, what sort of expenses that they would have in terms of capital investment, maybe the freezers that they've got, or a machine that makes waffle cones. We've discussed how labor costs are recurring and how in some ways it's fixed because you've got to have somebody at the store regardless of whether you're selling ice cream, but then depending on the level of activity, how it may be variable as well. So this is a list of, in most projects, there's some sort of a cost or a revenue associated with each one of these categories, and additional description of what they all are is provided in the textbook. It's a general principle that the more accurate your estimate is going to be, the more time it takes you to generate it, and the more expensive it is to generate that. And so an order of magnitude estimate is an estimate that may be good to within 30%, or even may have more error than that. An order of magnitude estimate is, if I was going to ask you, how much does it cost to make an iPad? Is it $50, $500, $5,000? And sometimes you need to know an order of magnitude estimate in order just to throw out a possibility. And to give you an idea of an order of magnitude estimate that I saw recently, is there are these little printers that will now, instead of printing with ink, they print plastic. You may have seen 3D printers before, and so I'm interested in getting one. You know, it seems like something that would be useful to integrate into the CAD course, but I had no idea how much they cost. It turns out that they have some of them that cost between $10,000 and $30,000, but some companies have come up with these 3D plastic printers now that are only $2,500, $3,000. And so you sometimes see technical equipment and you're really interested in it, but really don't have any sense for how much it may cost. And an order of magnitude estimate is just that easiest way of finding how much the expense is. And usually you don't have to go into too much more detail than just work breakdown structure levels 1 and 2. The more detailed the budget is, the more accurate the projection is going to be relative to the ultimate actual cost that is borne. But of course, you have to go into increasing levels of detail in order to achieve that improved estimate. Besides the amount of time that you have to put into generating the estimate, there are some things that are harder to estimate than others, and part of the reason for that may be variability in costs. Some costs are very stable, but some costs jump up and down a lot. The cost of copper is something that's been very scattered over the last several years, and I think it's particularly difficult for electricians to know what their costs may be when the price of electrical wire is jumping up and down, mostly up. But then there are some things for which the cost is relatively stable over time. And where to get the data is sometimes a factor that determines how difficult it is to generate a good level of accuracy. Some data is readily available online, other data is more proprietary, and you have to get a specific quotation, and the added time and expense of doing that can make it more challenging to get an accurate estimate. So this is a figure that shows that the estimating the cost of the project can be an appreciable cost of the project itself. This is kind of ironic that if you spend too much time getting quotes and trying to track down the best supplier for something, you may end up spending more money trying to save a few bucks than you end up actually saving. And if you think about how some people almost obsessively shop for the best value in airfare, my parents do this a lot. You know, they'll search online for 2 or 3 hours trying to find the cheapest airfare, and you know, ultimately maybe they will find something that was $20 or $30 less, but they've wasted several hours doing that they probably could have made more money than they end up saving. And so the corollary to that is, you know, for a business that's trying to get an accurate estimate of cost, sometimes having the cost estimated down to the penny is going to be so expensive to generate something with that level of accuracy that it isn't justified. So you really need to ask yourself at any particular part in the project of how much accuracy do I actually need. Okay. One of the techniques mentioned in the book on how to estimate costs is to use indexing. And at the top there is a formula that introduces the idea that you can find the cost in one year by finding out what the cost in the previous year was and then multiplying it by an index or a ratio. What the index does is sets a baseline. It says, let's consider a certain year our baseline, and then we will track over time how costs change relative to that baseline. So that the index in year N relative to the index in year K becomes a multiplier. So in this example, what we know is that in 1984, a baseline of 100 exists for purchasing and installing a boiler. So we just say the average boiler costs 100 to do that. Now, the index itself is unitless. And in fact, the number 100 isn't particularly relevant. It may have cost more than, it doesn't mean $100 or $100,000. It's just we're saying it is by definition 100. And so that in some year in the future, in 1996, if the index value is 468, then we can reference costs in the future to what the cost was in 1984. So in this example, we know that in 1996, the cost was, the index value was 468. And so what is the cost of the new boiler in 2011?
In this example, we're going to be finding the cost of a new boiler using indexing techniques. In this example, we know that today we're going to say is 2011. Just for sake of illustration, it's 2011 now, and we have some information about what the prices of boilers were in 1996. We're given the general formula that the cost in some year is the cost in a previous year relative to a ratio of indices. Now, an index is an idea of the relative cost of things in a certain year. In this example, N, which is the present year, is going to be 2011, and that past year, where we have the data for, according to the problem statement, is 1996. And so the way that we're going to apply this formula is we can find the cost in 2011 by entering the cost in 1996 and then multiplying that by the ratio of the two indices, the index in 2011 and the index in 1996. Okay, so we were given that the cost in the cost in 1996 was $525,000. So back when they installed the previous boiler, that was the price that they paid. But the price of things in general has gone up since 1996. And we know that the average item that cost $468 back then now costs $542. So this ratio is the ratio of boiler costs nowadays relative to boiler costs back in 1996. And so we can use that ratio to find that the predicted cost of the boiler nowadays should be $608,013.
We can take this indexing technique a step further, and the way that we do that is by considering what are called weights. And sometimes it's not just a single good that we're interested in. Sometimes it's a basket of goods. And in the case of a building, we think about that it's not just one material that goes into a building, but there's lots of different things. And the carpet may be 1% of the total cost of a building, and maybe wood is 10% of the building's cost, and roofing is 20% of the building's cost. And so if all of those different components are changing over time in their price, you'd need to know their relative importance or their relative weight in a project's cost in order to find an overall indexed cost at a certain time. And so now here in this example, what we're saying is that we know that regular gasoline there's 3 times as much regular gasoline sold compared to premium or plus. And so what we could say is that W1 of being the regular gasoline, W1 is 3, W2 representing the plus gas is 1, and W3 is also 1 for the premium. What we know is that in 1992, it had the prices that are shown there. 96, we've got an idea of the prices in 2006. And so in question A, what we're trying to do is find out what was the weighted index in 2006, when in 1992 the index was 99. So we are going to multiply the index in 1992 by the relative weights multiplied by the costs in each of those years. So if we're going to find I sub n, where n is 2006, it's going to be I for 1992 multiplied by that weighting formula that's shown at the top. So I'll give you a few minutes to solve part A, which is develop a weighted index. We want to know I for 2006. Okay, so hopefully you've worked through that part A and you know that the index is 227.5. I've got the calculation shown on that PDF if you want to have a glance at that, if you came up with any different answer. Moving on to part B, let's use the index for 2008. If we know that the index in 2008 is going to be 253, then how would we use the index in order to determine what the costs are?
In this example, we're going to find the weighted index for gas cost. So in the last example, we applied an index. In this example, we're going to find how that index can be calculated. We've got a variety of information. The table that's provided gives the cost of gasoline, each of the 3 grades of gasoline in the years 1992, 1996, and 2006. And what we'd like to do in this example is, first of all, calculate what was the index in 2006. So, develop a weighted index for the price of a gallon of gasoline in 2006. The general formula for that index, to find it, is that the index in 2006 is going to be equal to the index in 1992 multiplied by the current prices. And the weight means that there's more people using regular than the other grades of fuel. And so the weighting term that I've just written is going to be a way for us to account for the relative abundance of each of the 3 grades of gasoline that gets purchased. We'll have the weight of the plus grade of fuel, and then multiply it by the ratio of the cost in 2006 to the cost in 1992. These are the costs of each of the individual grades of gasoline so that we can find an overall average weighted index. Cost in 2006 relative to the cost in 1992. Alright, so we can substitute in that information now. It's given in the problem statement that the index in 1992 was 99.2. So the reference year, 1992, the index was 99.2. As for the weightings, we know that 3/5 of the gasoline that gets sold is regular, and so that's why we're going to put in that weighting term of 3 divided by 5. The cost in 2006 is $2.21 relative to the cost of the regular grade of gas being $93 back in 1992. And now the weighting factor for the plus grade of fuel is 1/5, meaning that 1/5 of all the fuel that's sold is plus grade. 230 to 103 is the ratio of the prices from 2006 to 1992. And then 1/5 of the fuel is the premium grade. And so it's 240 relative to 114. Alright, so we can go through the calculator and find that the overall index in 2006 is going to be 227.5. That answers the first part of the problem. That's the answer to part A. Alright, now in part B what we need to find is if the index in 2008, the overall estimated index is 253, then what will be the prices of each of the individual grades of fuel? Okay, so we're given for the index in 2008 being 253, then what will be the cost of each of the grades of fuel? So now we're getting to use an index again. The cost of regular in 2008 is going to be the index in 2008 relative to the index in 2006 multiplied by the cost of regular in 2006. So we know that prices have gone up a little bit, and the price in 2008 of the index, that's the overall weighted average, is 253 relative to 227.5 back in 06, and then the individual fuel cost just for regular was 221. And so the cost of regular in 2008 is going to be 246. If we want to do the same thing for plus, the cost of plus in 2008 is going to be the index of 253 to 227.5, and then we're going to multiply that by what the individual cost of the plus was back in 2006, which according to the table is 230. And so that tells us that in 2008 the cost of plus fuel should be 256. And finally, the same reasoning applies for premium. That in 2008 it's going to be the ratio of 253 to 227.5 multiplied by 240, which was the cost of fuel, premium fuel back in 2006, and so the premium fuel in 2008 should be 267. And these three values represent the answer of part B.
So think again about why this would be used and how maybe you have seen weighted index like this in your own life. An example that I remember from my childhood was a grocery store that I would go to had a basket suspended from the ceiling, and it was a basket full of lots of different things from the store. You know, it had a carton of milk, it had cereal, some vegetables, canned goods, and what they had done is they had gone through their store and added up the price of all the things that were in that basket, and then they sent someone to a competitor's grocery store in town. And so they had two baskets with the same thing in it, and they said what their price was, and then they said what the price at the other place was. And they were making the point that you'd save more money if you shopped at their store than at the competitor's store. And so that basket was a weighted average. The government comes up with weighted averages as well. There's something called the Consumer Price Index, and you can find the Consumer Price Index on the Bureau of Labor and Statistics website. And I went online this evening and I looked up the most recent news release for the Consumer Price Index and the nationwide city prices. And what you can get a sense for there is that prices have changed slightly since the previous quarter, and on a year-to-year basis, they show different types of items, and they also have relative weights that are listed. They have an estimate of what a typical American spends on certain things. Their estimate is that, for example, the typical American spends 14% of their budget on food. And so when they're trying to come up with an index of the prices that consumers face, they would multiply their own weighted index of different subcomponents. And so they're saying for food, 14%, and people spend 8% of their overall budget on food at home, and 5.6% of their budget on food away from home. And so you can see it goes into additional detail for the food at home. There's a certain amount allocated for cereals and bakery, meats, poultry, fish, and so on. And then you can see how each of those things have changed over time. And it's interesting to go through that and see where the prices have increased and where the prices have decreased. Over the last 50 years, it's really remarkable how much less people spend now on their clothing than they used to. We spend a lot more on fuel, but a lot less on clothing, less on food. And so, although prices of some things go up, prices of others decrease. And this consumer price index is just an example of a weighted average for lots of different prices.